Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hey, good evening, everyone. Welcome to day 19 of our Learn and Earn series. Please, quickly, everyone in the chat section can let me know if my voice is audible. And if my screen is visible. Hi, Shubham. Hi, Sachin. It's okay, Naikas. You can always cover those sessions from the channel. The playlists are there. Okay, thanks, Shubham, for confirming. Yes, thanks, Meshkat. Congratulations, Krish. That's a very good news. All right, guys, let's just wait for a couple more minutes. Let's rest of our friends also join, and then we shall be starting our today's session. Thanks, Indranil. Thanks, Naikaj. Okay, so how are you all till then? We have some time. So in the chat section, let me know how you all are doing and what is the maximum streak that you guys have achieved till now. It's day 19. Quite a consistency you all have maintained. So congratulations for that. Great, Shubham. 19th day, great. All right, Priyanshu, what you will have to manage time, right? What you can do is for staying consistent, at least try to do 2-3 questions every day, say in your exam days. And when you are having some free time, when your exams are not near, then what you can do more than 2-3 questions for your practice, right? So that way you can stay consistent. It's okay, Naikash. You can submit it today whenever you get time. All right, guys. So I think we are good to start with our today's session. Okay, so quickly give me a +1 in the chat if we are good to go with our today's session. Okay, so yeah, let us start our today's session. The first question, thanks Naikash, thanks Shagun. Okay, so the first question of our today's session is longest common substring, right? Okay, so the question statement reads as given two strings, the task is to find the length of the longest common substring, right? Okay, first thing, what is the difference between a substring and a subsequence? Everyone in the chat section, please comment. What is the difference between a substring and a subsequence? Continuous substring. Good evening, Rish. Substring is continuous, but subsequence is not continuous. Yes, Sachin, that's the right answer. Okay, so we are clear on that part. What is the difference between substring and subsequence? All right. Okay, so longest common subsequence that we have already covered in our previous session, right? Now we have longest common substring. So as we are already clear what is the difference between substring and subsequence, let us move towards solving this. Okay. This one is A, B, C, D, G, H. Okay, so say two strings are given to us. Just a second. Okay, so two strings are given to us. String one is A, B, C, D, G, H, and we have our string 2 as A, C, D, G, H, R. Okay. Yes, Krish, Shubham, thanks. That's the right answer. Okay, so we are doing here longest common substring. Okay. So we have our S1 as ABCDGH and S2 as ACDGHR. Now, what is the LCS that we have here? The longest continuous. Okay, one we can see is, okay, so here we are having, let me change. Okay, so here we are having A and A, that is common. All right, so that can be one of our potential answers. Now B is not in this string, so let us ignore it. We have C, here also we have C, then we have D, here also we have D, then GH. Okay, so here also we are having it, then we have CDGH. Okay, now what we need to print is we need to print the longest common substring, right? So our answer longest common substring will be CDGH for these two strings. Okay, is this clear? Is this clear, like what the question is demanding from us? Hi, Adarsh. The question is to find the longest common substring. Okay. The length of the longest common substring. Okay. So is this clear? Okay. Thanks, Shubham. So what are we going to do is, first of all, see, let us try it. Try this doing with a recursive approach, right? See, what we have done is we had our S1 as A, B, C, D, G, H. And then we had our S2 as A, C, D, G, H, R. Okay. Now see, what is happening here is, let's change color. Okay, so what we have done is, first of all, we are checking for this first string. Okay, first character. Is it a match? Yes. So if our first character, okay, as we are using recursive approach now, so let us begin from the end of the string, because in recursion we always start from large to small, right? Okay, so here we are checking for our last character H and R. Are these two characters common? No, the last character is not common. All right, so we need to decide that whether, as our last character is not common, so in this case we need to decide that whether we should be moving ahead by taking this character with us or by taking this character with us. All right, yes, it can be done with iterative approach as well. I'll be coming to it, but I want you guys to have this logic building, that how we can go from recursion to iterative, right? Once you build that logic, then it will be very easier to you to solve such kind of questions. All right, so is this thing clear? H and R were not common. Okay, so we need to discard these characters, and we will be either moving forward with H and we will be either moving forward with R. All right, that we need to find out. Okay, so that which character we have to take, and that we use recursion for that. We will check that by picking up which character and by removing which character we are getting the maximum length. Okay, so whichever will give us the maximum length, we will proceed with that. All right, so let us, okay, let us see, if we have A, B, C, D, G, H, and say the next string is C, D, G, H. Okay. Tell me one thing. Is this last string a match? Is a last string match? Sorry, last character. Are last character same for both of these strings? Yes, thanks Shubham, thanks Rish. Last character is same. All right. Okay, so now what are we going to do is this 6. The length was 6 and here the length is 4. So now as the last character is same, so what are we going to do is we will now proceed towards the previous character. Okay, the last character we have evaluated, we will now proceed towards our previous character. So we have subtracted length, right? I minus 1, j minus 1. Very good, Shubham. Okay, so now we are at G. Is this character same? The previous character, now length we are at 5 and okay. And here we are at 3. Is this character same? Yes, thanks everyone. So this character is also same, right? So now what are we going to do is we will again decrement this value. Okay, so now we are here at D and here also we are at D, right? Is this character same? Yes, this character is same as well. So this will become 3 and this will become 1. Okay, now we will move to our this character. This character is also same, right? So okay, length we have that achieved till now is 4. This character is also same. Okay, so now again we will go to one index previously. Okay, thanks Arbaz, thanks Shubham, Adarsh. Okay, one index previous. Here is B and here we have no any character. Okay, that means we length of the string has been covered. So what now? We are going to stop our recursive code, right? Stop our recursive code. Right. Is this clear? What are we doing? Like I'm explaining to you the first case when we have a character common and then we keep on iterating till we reach to a base condition. Right? Yes, Shumam, LCS is 4 here. All right. Is this first condition clear to you all? The characters were common, so we just keep on going to the previous characters, right? Now, let me explain you another case. No, we can't use sliding window approach here. Why? Because we need to find longest common substring, and for that you will have to do comparisons, right? In sliding window substring, just imagine the number of comparisons that you will be doing to find it, like longest common, and on top of that we are having two strings here, right? So that will be like a lot of work and time complexity will reach to, I guess, more than square time complexity will be there. So that's why. All right. Okay. Now see if there is an example, say A, B, C, D, G, H, and C, D, G, H, R. Okay. In that case, the last characters are not a match. Okay. They are not a match. So what are we going to do is we have two options, right? Either we can, in the next comparison, either we can compare these two. All right. Or either we can compare these two. Are these two possibilities clear to you all? Are these two possibilities? Why are we getting? Is it clear? Because see, the last character is not matching, right? So it means they will not constitute the part of our answer. Okay, so we need to, yeah, thanks Shubham. Yes, Shoaib. Okay, nice. Chaitanya, Shubham. Okay, it's clear that these are the two cases that we have. So this is the second case. Is second case clear to you all? So what are we doing is, in our recursive approach, if the characters are not a match, okay, it's not a match, then we have two cases here. Either we will proceed with I minus 1j, or either we will proceed with I and j minus 1. Is this clear? Thanks, Sahil, for confirming. Great, so it is clear. So what did we see here? That in recursion, there can be two cases. First case, the last character matches of both the strings. Yes, Shubham, that's very good. You are able to build the intuition. See, I could have directly started with the DP solution, right? It would have been helpful and it would have saved time, but that's not the thing. The main thing is you should understand that what leads us to select DP, right? It's not at the very first instance that you can look at the question and you can just think that, okay, that's a DP question, right? So you first need to build the intuition, and I'm very happy to see that you guys are able to do it. No, this string will work in either case, Arbaz, okay? Any string can be at any place. That will not create any difference. Okay, so what is happening is, if last character of both string matches, then we will recursively call for I minus 1, j minus 1, right? And if last character does not match, then either we will proceed with deleting element of one string, or either we will proceed with deleting element of another string, right? These are the two cases that we have. Are these two cases clear to you all? What are we doing here? Okay, please give a +1 in the chat section if these two cases are clear to you. Okay, there are only 2 +1s, so rest of you didn't understand. Yes, I will definitely summarize. All right, but if till now everything was clear, then just give me a +1. Okay, so I'm explaining again. What are we doing here is, yes, thanks everyone. Okay, so let us help our friends a bit who are having problem with this. Our aim is to find the longest common substring, right? So when you are finding the longest common substring, what is the case? See, A, B, C, D, G, H or C, D, G, H. So first condition that can exist is, so the first condition that can exist is either these character match, right? We are using first of all recursive approach, right? And in recursive approach, what is the thing? We start with the largest input and then we go towards making our input small. All right. So see, what can be the first case? That last character matches. Okay. So if last character is matching, then in that case, what you will do? You will simply move to the previous character to check if that is matching or not, right? Okay, if that is also matching, then you simply move to the previous character to check if that is also a match or not, right? So that is what we are doing. So if last character matches, what we do? We call our code recursively for I minus 1 and j minus 1. Okay, clear. Now, what can be the second case? This is the first case. Now, what can be the second case? Say string is A, B, C, D, G, H, and the other string is C, D, G, H, R. Now, see, in this case, the last character is not a match. Okay, in this case, the last character is not a match. So what we will do, either we will keep this character and check for this rest of the string, okay, deleting this. Because as we can see, if we delete this and then if we check for this part, we can get a longest common substring, right? So the first thing that we can do is, either we will keep this character and delete this one, or the second thing that we can do is, we can keep this character and we can delete this one, right? Both ways we have to do. But then as we want to find LCS, so what are we going to do? We will simply find maximum, that from where, by deleting which character we are getting maximum. Okay, so that's why in this case recursive code will be called for both the things. All right, and then we will select the maximum out of them. Is this clear? Are both the cases clear? Are we good to start with our coding part? Yes, thanks Aditya. Yes, we will move towards memorization as well. Okay, so we are good to go with the coding part. All right, thanks Sahil, thanks Shagun. Okay, so let us start coding. So yeah, as always, you guys will help me out in this coding part. We have to find the longest common substring, right? Let us first declare a variable here, and we will need a utility function where we will pass s1, s2. We are starting from n and m, and let us say initially we have the length of LCS as 0, right? And once we have evaluated this, we will return CTR. So this is our utility function. String x, string y, int I, int j, int CTR. Here, okay, now tell me what is the base condition here? If we are starting from the length of the string, right? So I just showed in one of the examples that in what case our code stopped, right? I mean, what was that base condition? Because it is a recursive solution, right? The base condition have to be there. So what it will be? Tell me quickly in the chat section what we will be our base condition. Well, we are already starting I and j from the length of the string. Okay, as you can see, we have passed n and m. As we have as I have explained in the example as well, we are starting from our last character, right? Length 0. Okay, thanks, Arbaz. That's the right answer. So if I is equal to 0, or if we have j is equal to 0, which means if either of the string is empty now, okay, if either of the string we have iterated completely, then we will simply return whatever value we have in CTR as of now. Clear? This base condition, yes, thanks Adarsh. Thanks for being so specific. Thanks. Okay, now what are we checking for? Base condition we are done with. Now, what condition are we checking to see if the given character will form a part of substring or not? We have to check if given character will form the part of substring or not. So, what will be the code for it? What we were doing in all these examples. S1, okay, what is S1 and what is S2? Let me do it. Screen is visible to you, all right? Shall I increase the font size just a second? Right. Sorry, x and y. Okay. No, x and y are string. Why? We can't compare string, right? What are we comparing exactly? Yes, we will compare from back. That's right. S of I is equal to S of j. That's very right, Shubham. But tell me one thing. Initially, we are passing n and m. So, do you think passing just comparing at I and j will not give us a runtime error? Character, yes, others. That's right. Naikat, Shubham, yes, both of you are very close. Yes. Okay, so we have a correct answer here. So what are we going to do is we will simply do if I minus 1 is equal to j minus 1, right? Is this clear? Then we will simply have our CPR as what? We will call it recursively for x, y. Okay, now what shall I write here? Tell me, what do I need to write here? If the end character matches, then what was the next step that we were doing? The end character was a match. Great, Sachin, Arbaz. Okay, that's the right answer. I minus 1, j minus 1, but we need to pass one variable as well. That's Naikash, that's the right answer. What's that one variable? That's CTR, okay? Yes, Adarsh, Chaitanya, all of you are giving correct answer. Okay, shall we pass direct CTR here? Here, what it will be? Will it be CTR? Just think over it. If it will be CTR, then are you updating the value of the substring if they are a match? Like we need to update the length, right? Yes, Adarsh, that's right. It will be CTR plus 1, okay? Yes, thanks, Naikash. It will be CTR plus 1. Now, if the character is not a match, then let us say we need to, okay, let me declare two variables here first of all. Now let us say they are not a match. Then in that case, we will call our function recursively by taking character from one of the string and deleting character from the other string. Okay. Okay. Now what shall I write here? What will be the value of CTR if the character is not a match? CTR minus 1. Okay. See, this is a substring, right? Check if. Uh, okay, let me go to the example part. Say we have a string here as A, B, C, G, H. And here we have a string as B, G, H. Okay. And okay. These two are match and these two are a match. Okay. So currently we have our length as 2. Now, this is not a match, right? This character is not a match, all right? So shall we now, like, what will be the current length, I mean, for which we shall be iterating? Will it be 0 or shall we continuing with this length 2 only? This is a substring, right? Keep that in mind. So will it be 0? Yes, Niraj, that's the right answer, that we need to check new substring. So CTR will become 0 now. See, has it been subsequence? Then in that case, we can proceed with this length. Okay, because strings need not be continuous. Sorry, characters need not be continuous. Right? So that's why we can start with, we can keep on doing with this length. But in this case, it is substring. Okay, so we need to change our CTR to 0, because every time we are starting in new with a new case, we need our CTR length to be 0. Okay, so that's why our CTR will be 0 in both of these cases. So writing it here, and then at the end, the final answer that we need to return is, okay, no. First of all, we will have to put the maximum value, that by doing which of the operations we are doing maximum. No, old one will not be lost. That part of code I'm writing, you'll not be able to lose the old part, right? And thanks for raising this question, Arbaz. Okay, so CTR will be max of CTR, CTR1, CTR2. All right, here we are storing the maximum. As I said, there were three operations. The first was if it's a match. The second operation, the two operations are from if it's not a match. Okay. So we are going to add the maximum from all these three operations in CTR, and then at the end, we will return CTR value. Okay. Now let us see what this code gives us. Okay, there is a compiler error. Okay, so as this is a recursive approach, so we can pretty much expect to get a time limit exceeded. All right, and this is a TLE, right? Okay. So, okay, is this recursive approach clear to you all? We shall be slowly moving towards our better approaches that we can do. Is this recursive approach clear? Give a +1 in the chat section if you guys feel that you are now very much comfortable with this recursive approach. All right. Now, see, to optimize this recursive approach, what is the first thing that comes in mind is what shall be our next step to optimize this recursion? Yes, memoization. We have a correct answer here. Okay, before going to DP Nikhil, let us first understand what is memoization is. Okay, so now tell me what is the difference between a recursive approach and a memoized approach? What exactly do we append in memoization approach? What exactly are we doing? Why is it called memoization? There must be some meaning to it, right? Memory allocation. Okay. So how memory allocation is done? Yes, we have a correct answer. We cache the calculation in memoization. No need to calculate process input. Wow, the all of the answers that you guys are giving, that's perfectly correct, and I'm very happy to see this. Okay, so we know what the memoization is. Okay, so now help me to memorize this code. First of all, let us see what are the constraints are. 1000. Okay, so here I'm doing memory allocation, right? We store the value. Yes, that's perfectly right answer. Store pre-calculated. Yes, Nikaj, Adarsh, yeah. And let us see, let us create a global variable for our answer as well. Okay. Now to initialize it, we all are familiar with nameset function, right? See, I'm not going to write a new code. I'm just saying that how with the help of a memoization, this recursive approach, you can just, do some little changes in this recursive approach, and then you can change it to memoization. Okay, so that's why I'm coding it in the same part so that you guys can see what are the changes that we have done, right? So we are clear, right? We have here allocated a 2D array so that the calculated value can be stored here, and this global variable is there for our answer. Okay, yes, so we are clear on that part. So let us just call our LCS. We don't need a CTR here, and after the calculation we will be returning our answer. Okay, now we are good to go. So, okay, if I is 0 or j is 0, we have reached to the end part. We will simply return 0, right? Now, before returning 0, here what you have to do is before returning anything, just make sure that you are already storing it in the array, right? So now before returning it, we will store it in the array. That part is done. Okay. So next we have is if it was a match, right? If the characters are matched, then we are returning this. As I said, in this case, before returning anything, make sure you are storing it. So here we will need a new variable with us to calculate the values. Now, here comes the importance of memoization. All right, why we have memoized our code. We will check that if t at ij is not having -1. See, initially we have allocated -1 to all the elements of the array, right? So now we will check that if it is not -1, it means it has already been calculated. So we will simply return t at ij. Why? Because it means that it has already been calculated. Is this clear? Great. Now see, if it is a match, right? In match case, what are we going to do is, we can just simply copy paste this, not some major changes. Okay, but rather than doing CTR plus one here, let me add one here. Okay, we have increased one length. Okay, because that was a match, so our length has been increased, and we will be storing our answer. Why we are storing our answer here? So that after the entire array is processed, we don't need to reprocess it again to get the max answer. All right, that's why we are already updating here. And again, we'll have this CTR1, CTR2. Now we don't need this. All right, is this clear? I mean, what we are doing here is, and yeah, we don't need this line here as well because we have calculated our max. Okay, now tell me, before returning CTR, what shall I write here for memoization? Answer is a global variable. Okay, we have declared it here so that we don't need to pass it in the function. Just to save some writing. So now what shall I write here before returning CTR? What shall I writing? Okay, so this is where the memoization is coming into play. What shall I write before returning? Ans ij. Ans is just an integer value. It's not an array. The array is t. See here, when we were returning 0, what did we do? We first added 0 in our array, right? Yeah, exactly. Thanks, Shubham. We need to store it in the cache. Okay, so for storing it in the cache, what shall we do? For storing it in the cache, what shall we do? Okay, Adarsh, I think you meant Tij, right? Yes, Nikesh, thanks. Okay, now I need to write here Tij. This is, we have done the memory allocation and now our Tij is having the value of CTR, right? So here we are allocating the value in this line, and in this line we are allocating the values, and then here we are checking that if the value is already computed, then we will not compute it for ith and jth index. Okay, yes, Gaurav, that's the right answer. Let us see results. All right. Okay, so this is also giving us a TLE. Okay, that's because we have used memoization, and in memoization as well, space and memory is taken. So what's the best solution then? Let us erase all this and let us write our best solution. All right. So now what we should do? Yeah. Yes, thanks. Okay, so is the recursive approach and memoized approach clear to you all? Go with tabulation. Yes, exactly, Nikaj. Okay, you were all able to figure out, right, that how from recursion we went to memoization and then tabulation. Okay. Yes, bottom up approach. Thanks, Shubham. Thanks, Nikaj. Thanks, Adarsh. Okay. Okay, so this will not take much time. Let us just code. Here I'm declaring an array, right? Just like we have done. And let us say our final answer is 0. Now we will start our iteration. Right, we are iterating for both the strings. Now what was the base condition that we were using in memoization and recursion? Okay, CTR1 and CTR2, we evaluated them, right? And then we are checking that which is giving us the maximum, and then that maximum we are passing in our answer. Okay, so now tell me, what was the base condition here while filling the table? What base condition did we have in recursion and in memoization? Yes, correct. I is 0 or j is 0. Right. See, in this case, we are starting from 0. So what does this I0 or J0 means? Let us say, okay, so this is the table that we are creating, right? Let's say this is our table. Now say this is I, this is J. Now say one of your strings is empty and other string is whatever, say ABCD. So if this string is empty, right, I is 0, we are here. If this string is empty and no matter whatever length this string 2 have, whatever is the value of J, right, whatever will be the value of J, we are not going to get any substring common, right? That's why all of these values will be filled with 0. Is this clear? Same thing for the opposite. If S1 is something, say AB, and if S2 is empty, then no matter whatever is the length of the S1, you are not going to get anything in common. That's why 0. Is this clear how this base condition is getting filled in this table? Is this clear how we are filling that base condition in the table? Yes? Everyone, please give a +1 in the chat section if this is clear to you all. How the base conditions are getting filled in the table. Thanks, Shubham. Okay, so there's only one +1. Okay, thanks, Adarsh. So, yes, we have to create 2D array that we have created here, right? So, this is how we are filling our base condition. Okay, if either of the string is empty, then we are not going to get any common characters, right? So, that part is done. So, if I0, J is 0, we will simply write Ij is equal to 0. Clear? Else if, now we are going to check if we have a match. Yes. If we have a match, then what shall we do in this case? What will be the value of Ij if it's a match? Yes, first row is 0. Okay, if it's a match, what are we doing? We are doing two things. First of all, we are incrementing the size of our longest length that we have, and then we are moving a step forward. Okay, so value of Tij will be 1 plus whatever value we have calculated till now. Okay, no, we don't need to mark it 1. We need to mark it till whatever is the longest length that we have till this point. Yes, and then let us store our res as well. All right, so this is our updation, and let us see it's not a match. Then as it is a substring and not a subsequent, so what shall I write here if it's not a match? Great, it will be 0 because it is a substring. Yes, diagonally previous, yes, right? Yes, okay, because you see diagonally previous means what? Say this is our array, right? See, at this point it is coming a match. 0 1 0 1 2 means A B C B C. Say at second index we are getting a match, right? So if at second index we are getting a match, then we need to check whether it was a match at previous index or not, right? So to previous index, what will be the previous index for this? We will just do I minus 1 and j minus 1, right? Here we are here we are doing I minus 1, here we are doing j minus 1, right? So whatever value we have at I minus 1, j minus 1, we add 1 to it. Okay, great. So yeah, and then we have 0, and then at end we will be returning this. Okay, great. We have solved this question. So is this clear How from recursion to memoization to tabulation? Is the approach clear to you all? Yes, clear? Great. Okay, thanks. Okay, now so I want each one of you to please give a like to this video as well, right? Please just do that. All of you who are watching this video, do give a thumbs up on this video so that we can just keep a track of the viewers. Right. Are we good to start with our next question? Thanks, Adarsh. Are we good to start with our next question? All right. Okay. Before moving to the next question, the time complexity is n square and space complexity n square as well. Okay. All right. So our next question is longest palindrome in a string. Okay. So before discussing about palindromes, okay, quickly in the chat section, let me know about some of the palindromes, like valid palindromes. Okay. Not just any random string, because we have those random strings in our questions. So let me know some of the valid palindromes that we have. Madam, yes. Radar, yes. Aditya, that's right. I said I want valid, I mean the strings which make sense. For example, Adarsh said madam and Aditya said radar. So yeah. Okay, so we are clear what palindromes are. Okay. So let's not just wait time. Yeah, ma'am is correct one. Okay, so we are given a string and we need to find the longest palindromic substring. Okay. And we need what is a substring. We know what is a substring and we know what is a palindrome. Okay. So for example, here this is okay. So this is the longest palindromic substring that we have, right? Clear? Yes, level is the right answer, Aditya. That's a palindrome. Okay, so this is the palindrome, right? If we have A, B, C, then what is the longest palindromic substring for this? What is the longest palindromic substring for A, B, C? No others, that's not a palindrome. A, yeah, longest palindromic substring is either A, either B, or C. Okay. Thanks, Kanishth. Okay, so I'm very happy that you like the questions. Okay, so we have longest palindromic substring. Either it can be A or B or C. Okay, so we need to find LPS. So just tell me one thing. Longest palindromic substring. The substrings can be of two lengths, right? Either it can have an odd length or either it can have an even length, right? This was the palindromic substring. What is the length of this substring? 6, which is an even length. Okay. So now tell me one thing. Every palindromes, okay, let us say a string is given to us. Okay, so every palindrome is there. We can do one thing like see. We can first of all check here if any palindrome can be formed with A at its center. Is it possible to form a palindrome with A at its center? Of course not, because A is the first character and there is no character here, so we can't form a palindrome here, right? Of course, a single length palindrome is possible. I mean, A itself can be the palindrome. Okay, yeah, even character matching. That's right. So see, what are we doing? Okay, this is our A. We will check here. Is it possible for us to form a palindrome with having A at its center? How we will check? How are we going to check? Yeah, we will just okay. A at its center, A in itself can be a palindrome, right? Now, what we will do is we will just move a step backward and Yes, Nikers, that's a very right intuition. We will start matching from the center. Both left and right should be same. Okay. So let us say we are taking A as our center. Okay. So we will be moving one step backward and we will be moving one step forward, right? To check if that's a match or not. And is that a match in our case? Yes, both left and right should be same. Great. In our case, is that a match? We have started here and we have moved one step forward and one step backward. Okay, it's a match. So we have a palindrome with us whose maximum length is 3. Great. We will again move one step forward and a step backward. Okay, as we have moved step backward, we are out of index, right? Good evening. Okay, so we are out of index. So now we will stop our loop. Okay, that's the end condition, termination condition. So let's stop our loop, right? Okay, now let us say we are taking this string as our center. Okay, this character as our center. Now if this character is in the center, is it possible to form a palindrome with this character at its center? We will take a step forward, we will take a step backward. We are on this. No, it is not possible because step ahead is B and step backward is A. So that's not a palindrome, right? It is not a palindrome. So let us discard it. Now next we are at B. Is it? Okay, say let us write B here. Okay. Taking a step ahead, taking a step backward. Are the characters same? Are the characters same in this case? Great. So let us add them. All right. And now let us again move a step forward and a step backward. Are the characters same again? Yes, they are again same. We have A, we have A. Okay. So let us write it here. Now let us, we can't take the step forward, right? Why can't we take it? Because we have reached the termination condition. Okay. So let us just stop our loop. And is this a palindromic string that we have? Is this a palindrome string that we can have? Which is the maximum length is 5. Okay, so we have our answer with us. All right. Great. So here we have our answer. So is it clear to you what we all are doing? We are just taking a center. We are moving ahead, moving backward until character matches. What is the first condition that we are checking is until the character matches. And what is the second condition that we are checking is we haven't reached the termination. Okay. We haven't reached termination. Is this 2 points clear to you? Yes, both are palindrome, but we need to have the longest palindrome. That's why this AABAA is selected. Is this 2 condition clear to you? We are taking each character of the string as the center of palindrome, and then we are checking if they are forming a valid palindrome or not. All right. On what basis? The first thing, character must match, and the second thing, we haven't reached the termination. Are these both condition clear? Give a +1 in the chat section. Okay, see, for the even length, the approach is going to be same. The only difference will be, see, it is for odd length palindrome, but say for even length palindrome, we will keep one of our pointers here and other pointer will start from I+1, right? In odd length, both the pointers were starting from I, but in even length palindrome, one pointer will be at I and other pointer will be at I+1. Okay. Is this clear now? Yes, Adarsh, it will work for even. Just we need to change the starting point of our pointers. Okay. Once you will do that, it can see in this case we have a even case. See, for even palindromes, what we have two centers, right? Say A, B, B, A. This is an even palindrome. So for even palindrome, we have two centers, right? So we will keep one of our pointers here and one of our pointers here, and then we will keep on going forward and backward, depending on the condition if the character matches. Okay? Clear to you all? Okay, are we good to start with coding part? Give me a +1 if we are. And like, is the logic very much clear to you all what we have done? There is no rushing. Take your time to understand the logic. If any doubts, do ask in the chat section. Just try to process it, okay, what we are doing. Okay, so you guys are clearly able to figure it out. Great. Very nice. Thanks, Aditya, Naikaj, Adarsh. Okay, so let us start with the coding part. So what we have done, first of all, okay, so we need to return a string that yeah, implementation I'll just show. Okay, we need to return the string, so we must keep a track that what is the first point from where our palindrome has started. Okay, so we will keep a track of the first point, and then we will keep a track of the length. All right, with these two things we will be able to return string. Now this palindromic substring. Okay, now let us move to the coding part. Clear to you all? Great. So we have, let me, n is dot size. Okay, and let us say the max length that we have adding, max length that we have is no, which it should be 1 hair. Okay, so everyone knows why it is 1 hair, the max length. Everyone knows why it is 1. Okay, and then rather than coding it for that part as well, we can simply return else if n is less than 1, because in that case, single character is always a palindrome, right? Okay, so and we need to keep a track of start index as well. So let us say for now our start index is 0. Okay, so first of all we are doing it for odd length palindrome. Okay, so for odd length palindrome, okay, for n I is equal to 0, I is less than n I plus plus. Okay, let us say, is this clear? What are we doing here is, yes, one character will always be a palindrome, that's right. Okay, zoom, let me do it. Okay, is this visible now? Wait, font size 22, and then let me enlarge this. Okay, is this clear now? Let us say my lower index start from I and my upper index start from I as well, because we are doing odd palindromes. Okay, so it will have one center only, right? Now what are we going to do is, L is our lower bound, right? So while L is greater than 0, L should, no, first of all the condition we must check is asset L must be is equal to asset J. Is this clear? We are checking if the characters are similar or not. Okay, and if they are similar, then the next terminating condition is L should be greater than 0. Okay, and R should be less than N. Okay, so what are we going to do if this condition is there? While it's a match, what are we going to do? L minus 1 and R plus 1. Great. L minus minus R plus plus. Great. That we have done. Now, once we have evaluated this, we will need to check that what's the length. So length of the string will be upper bound minus lower bound minus 1. We shall update our max length. That will be the maximum of, yes, that's the right answer, maximum of max length and length. No, as we need to update the start index as well, so we will check that if length is greater than max length. Okay, in that case we will update our max length as length, and we will have our start index as l plus 1. Okay, now why l plus 1, tell me? Why I'm writing my start index as l plus 1 and not l? Okay, yeah, let us see if this code is working, and then we shall do the amendments. Yeah, that is the condition as well, because first of all we have to check the termination. That must be a valid. Okay, tell me why start is l plus 1. L is not equal to R. No, I'm telling, I have started my, we are moving forward. No, as we are, see, as we are going backward in the case of L, okay, as we are going backward, so after the final iteration, we have decremented the value of L. So at this point, there is no matching, right? So to match the string, the last L which matched, that was at L plus 1. So that's why the start will be at L plus 1, right? So that we can do. Is this clear? How we are doing? Now let us do for even length. That will be pretty much same. Let me just copy paste it. Or you guys can just, make a function and do this. Okay. The only difference will be here we are starting from I plus 1, okay? And then this will remain same. And then at the end we will return s dot substr starting from start and length. We know this substr function, right? Oh, yes, that's the correct answer. Okay, so let's just compile and run. Okay, I'll just explain it. Start is equal to L plus 1. I'll just explain. Okay. Okay, there's a compilation error. Okay, it's not J, it's R. And here as well, it's not J, it's R. Thanks, Shubham. Okay. Okay, so we have solved this problem successfully. So yeah, kudos to us. Now let me explain why start is L plus 1. Okay. See, say if this is our string. Okay, let us say we have taken B as our center, right? Yeah, Gaurav, I'm explaining this. Let us say we have taken B as our center. Now this is 0, 1, 2, 3, 4. Odd length it is. L will be 2, R will be 2. Okay, one step backward, one step forward. L will be what? 1, R will be L. Uh, Initially L is 2, R is 2. Okay, one step backward, forward. L will be 1, R will be 3. Okay, again it's a match, so we will move a step backward and a step forward. So L will be 0, R will be 4, right? Again it's a match, right? And as value of L is greater than or equal to 0, so it will again move backward. So now value of L will be -1. So at the end of the while loop, value of L is -1, right? But that's not the correct index. The correct index was from 0. That's why we always start our string from L plus 1. Okay, so -1 plus 1 will give you 0, which is the correct point of the starting of the substring. Is it clear? Is it clear now why we have taken start as L plus 1? Because by the end of the while loop, L is getting decremented, right? So we don't want that decremented value. We want an updated value. So that's why. Okay, great. So yeah. Okay, so give a +1 if this question was clear to you all. And also please give a like to this video. Whoever is watching, just please give a like. All right, are we good to start with our next question? L we are initializing with the current value of I, okay? Thanks Gaurav, thanks Aditya, thanks Shishir, thanks Adarsh. Okay, so I'm very happy to see the responses and I'm very happy that you guys are able to grasp the concept. Okay, and this question is my favorite question of the day, and in a while you all will be knowing why. Because right, so the question is, we have to form a palindrome. Okay, so what does the question say? See, this question is very much of a concept rather than writing of a code. Once you will able to get the concept of this question becomes super easy. Okay, so we have to form a palindrome. Okay, what the question statement reads as, uh, we have been given a string and we need to find the minimum number of characters that are to be inserted to convert it into palindrome. Okay, so let us see how many of you are able to see the beauty of this question. This question is really my favorite. Okay, so this string is given to us. Now tell me, how many characters must be inserted to make it a palindrome? We need to make it a palindrome. So how many characters must be inserted? Okay. Come on, guys, tell me in this two. Okay, so two characters must be inserted, B and C, right? Great. Now, our string was ABC. If we want to make it a palindrome, how many characters must be deleted from it? Okay, either you can delete B or C, or say either you can delete AB, either you can delete AC. Any of you can do. Okay, so how many characters are we deleting? Two, right? Let us say this is our next string AA. How many characters needed to be inserted so that it can be converted into a palindrome? Zero inserted, right? How many characters must be deleted from it so that it can be a palindrome? 0. All right. Okay, see guys. For this question, we are going to have two very important concepts. Okay. Great. Thanks, Adarsh, Shahnawaz, Kamal, Naikaj. The first important concept, the first important conclusion that we just saw is to make a string palindrome, number of insertions is equal to number of deletions. Is this concept clear? Give a +1 if this is clear to you all. Give a +1 guys if this concept is clear. Okay, yeah, that is clear. Now let us see what is our second concept. All right. Okay. String longest palindromic. We have done longest palindromic subsequence, right? So let us say we have a string. We need to find the longest palindromic substring in it and the length of the substring and the deletions, number of deletions. Right. Say we have string as D, A, B, C, B. Okay. What is the longest palindromic substring in this? Longest palindromic subsequence, actually. Longest palindromic subsequence. Okay. The length is 1 only, I guess. Okay. Longest palindromic subsequence is how? BCB? Yeah, okay. So longest palindromic substring is 3. Yeah, right. So length of the longest palindromic subsequence is 3, right? What is the length of this string? 5, that is 5. Now, what is the number of deletions required to convert this string into a palindrome or number of insertions? Tell me the number of deletions or number of insertions required to make this string a palindrome. 2, right? Okay, great. Now let us say we have another string as BCD. What is the longest palindromic subsequence in this string? Yes, thanks everyone for the correct answer. Thanks Aditya, Naikaj, Shahnawaz, Kamal, Meshkat. The answers are perfectly right. Tell me what is the longest palindromic subsequence of this string? 1. All right. Length of the string is 3. Okay. How many insertions or deletions are required to make this string a palindrome? 2. Great. Okay. So for you to observe a pattern, let me take another example. AA. What is the longest palindromic substring in longest palindromic subsequence in this string? Yes, thanks for the correct answers, guys. What is the longest palindromic? 2, right? The length of the string is 2. And what is the number of deletions required? Of course, 0. The string is already a palindrome. All right. Is there any pattern that you can observe in these 3 examples? Tell me, that's the best part about this question. Any pattern that you guys can observe? Yes, as it is already a palindromic string, so no any insertions or deletions are required. Tell me if there is any pattern. Length minus longest palindromic subsequence. Okay. Great, Adarsh. Yes, Mohan. I'm very okay. Number of insertions and deletions are equal. Yes, that's conclusion. That was our first conclusion. Means first observation from this question that we have done. Great. So is everyone able to see this thing? Yes. Is everyone able to see this thing that length of the string minus LPS is equal to minimum number of deletions? Tell me, give me a +1 if everyone is okay with this concept. Give me a quick +1 or thumbs up if all of you are very much. Yes, Aditya, thanks for elaborating it. Yes, Adarsh, thank you so much. That's the right answer. Yes, exactly. This is the pattern that I wanted you all to observe, that the length of the string minus longest palindromic subsequence is giving us a minimum number of deletions. So rather than learning a new algorithm for finding longest, what was the question? Minimum number of deletions, right? So rather than, thanks Adarsh. So rather than learning a new algorithm to find the minimum number of deletions, we all know how to find the longest palindromic subsequence. Okay, length is already given to us, LPS is with us, we can find the minimum number of deletions, right? So the second observation for this question is length of the string minus LPS is equal to minimum number of deletions. Okay, so basically we don't need to do anything new in this question. It was all based on these two concepts. Is this 2 point clear? Sorry, are these 2 points clear to you? Just try to understand, try to analyze it very carefully, because as I've said, there is no any coding part to this question because we already know how to calculate LPS, right? Length is given to us and we can get to our minimum number of deletions, right? I want everyone to give a +1 if this concept was clear. Thanks, Aditya. Thanks, Nikach. Okay, great. So let us see. And as I wanted, thanks, Nikach. Okay, so as you can see, the code is already written, right? We just need to find the minimum number of deletions. So what are we returning here? The size of the string minus the longest palindrome substring, right? Longest palindromic substring of the string, okay? So that as you can see, this is the code to find the longest palindromic substring, okay? So is this concept clear? I have directly used, the tabulation for this. We all know how to calculate the LPS. Okay, one thing more. I just want you guys to make one more observation. Is this concept clear to you? Longest palindromic subsequence is equal to longest common substring of a string and its reverse. Is this concept clear? Like, are you guys familiar with this concept? This is what I have done here. See, if in a string, okay, you need to find the longest palindromic substring, then that is always equal to, sorry, longest palindromic subsequence, that is always equal to longest common subsequence of the string and its reverse. All right. So you can see, if you know only one thing, that is how to find the longest common subsequence, okay, you can solve this question, okay, with the help of knowing how to find the longest common subsequence, right? With the help of it, you can find the longest palindromic subsequence, and then you can get to the answer of this question. Is this clear? Anyone, any kind of doubt, please ask in the chat section. If you guys just know how to calculate the longest common subsequence, you can reach to the answer of this question. Yeah, of course I can elaborate. Let's see, we have a string, say A, B, D, C, E, G, H. Let us say we have, okay, this does not look anyway palindromic. Okay, see, this is the string that we have, right? What will be its reverse? A, B, C, D, B, A. Now, when you will find the longest common subsequence, what will be the longest common subsequence in these two strings? A, B, that is there. Then we have C, right? Then we have B, and then we have B. A, B, C, D, A. So this is the longest common subsequence that we get. Is it not equal to the longest palindromic subsequence of the S? Tell me, is this not equal to the longest palindromic subsequence of the S? Right? Okay, got it. So that's why just by knowing how to find the longest common subsequence, you can find the longest palindromic subsequence, and with the help of that, you can find the minimum number of deletions, right? So is this question clear to you all? It is just was okay. Thanks, guys. So you're welcome, Aditya. All right. So as you can see, that's the correct code. All right. So that was all about today's session. If any queries, any doubts, do ask, and keep on solving the questions from the SDE sheet. All right. Keep on practicing. Be consistent. Okay. And yeah, that was all about today's session, guys. Any feedbacks, any comments are very much welcomed. Thanks for attending. Uh, Thank you, guys. Thank you so much for the session. Do leave us with feedbacks and any queries that you have. Okay. See you tomorrow with some new set of examples. Thanks, Adarsh. Okay, everyone. Bye. Good night.